So as we take a look here at section 1 for honors geometry, identifying points, lines, and planes. At the end of the lesson, the idea is that you'll be able to successfully name and sketch geometric figures. Okay, so as we move through here, you'll notice that all the blanks are filled in here. So a point has no dimension and is represented by a dot. So i.e., that guy right there would be a point. If I label it like this, then the name would very simply be point A. Okay, point A, pretty simple. A line has one dimension, represented by a segment with two arrowheads, extends infinitely in two directions. Through any points there is exactly one line, and you can use any 2 points on a line to name it, or a lowercase cursive letter. So for example, if we look at something like this, and we call that guy our line, okay, again, two arrowheads, I call that point X, that point Y, and maybe this thing down here, there's a little Q. So the name of that thing could be line XY, and that's how we would mark it, okay, with a little line on top. We could call it line YX, or we could just call it line Q. Any and all of those are acceptable ways of naming that particular line, okay? And then finally, a plane has two dimensions. This is probably the hardest of the three undefined terms for students to understand. It has two dimensions represented by a shape that looks like a wall or a floor, but it extends without end in every direction. Okay? Through any 3 points not on the same line, there is exactly one plane, and you can use 3 points that are not all on the same line to name a plane. So for example, a plane looks something like this. All right, so there it is, and it doesn't matter. There could be potentially, maybe call it point A, point B, point C. So we could call this plane. So the way we do it is like this: plane ABC. Okay, and that would be sufficient enough. Using 3 points not on the same line. Okay, so to name a point, you use obviously 1 point. To name a line, you use 2 points, or a cursive letter, and to name a plane, you got to use 3 points. All right, so in example 1, give 2 other names for line LN. Line LN is the same as line LM, is the same as line B. Okay, those are all the same thing. Okay, I probably should have said line B instead of just writing the letter B. Okay, part B, give another name for plane Z. Okay, plane Z, notice that's this letter right here, so it's just kind of by itself. It's not a point, it's the name of the plane. So I can use any 3 points inside of that plane that are not on the same line. So I'm going to go ahead and call it plane. I'm just going to call mine LPN. Does not matter what order you do it in, none of that matters. It says name 3 points that are collinear. They lie in this. Collinear means on the same line. Co means with. Okay, you're a co-worker. You work with that person. So collinear means you're with that point on a line. So 3 points that are collinear. The only 3 here that are collinear are L, M, and N. Part D says name 4 points that are coplanar, i.e. they are on the same plane. Okay, there should be plane in here. I missed that word. Okay, points on the same plane. So there's exactly 4 points in the plane. There's L, M, N, and P. Okay. Notice it says not on the same line. You can have, as long as there's one of them not on the line, that is sufficient. Okay. If they were all on the same line, then you would be in a tough spot. It says use a diagram in example 1. It says give 2 other names for line MQ. Okay, again, this is kind of extending on what we just did, so you should be pretty good with this. 2 other names for MQ. You have line A, and we could just call it line QM. Okay, so MQ and QM are actually the same line. Name a point that is not coplanar with L, N, and P. M is coplanar. The only point not inside the plane is point Q. All right, again, hopefully this stuff is pretty straightforward, pretty simple. I know I'm going quickly, but the expectation is that this is pretty easy for you. Okay, so defined terms are terms that can be described using known words such as point or line. Okay, so a line AB written as, and I said this earlier, it's written like this. That's line AB, and points A and B are used here to define the terms below. All right, so now we're looking at different terms. Now we have segment. A segment, Okay, and when I write segment AB, it's A, B, and it's just a segment on top, 2 endpoints. Okay, consists of the endpoints A and B and all points on A and B that are between A and B. All right, so you'll notice in this particular, this guy is one endpoint, that's another one, and then all the points exactly between those 2 points are also on the segment. So a segment has 2 endpoints. A line has none. A segment has 2. A ray has 1 endpoint. Okay, and it's written. You always got to start with the endpoint and then the point that it goes through to name it. So ray AB is not the same as ray BA. All right, it consists of the endpoints A, it should be endpoint A, and all the points on geez, one word screws up everything. Okay, sorry about that. And all points that lie on the same side of A as B. So in other words, you started A, you go in the direction of B, and you include any and all points in that direction. Okay, and again, down there, note AB and BA are 2 different rays. Okay, so understand that. Opposite rays, okay, so if we have point C that lies on AB, on line AB between A and B, so i.e. looks something like this, call that guy point C, it's between A and B. Then CA, ray CA, and ray CB are opposite rays. Okay, in other words, they go the exact opposite direction and have the same endpoint. Okay, they have to be exactly opposite directions though. It says give another name for VX. Again, this is something you should be good at. Okay, VX is the same as XV. Name all rays with endpoint W. Okay, well, I'm just going to trace them here. I'll let you write them. You have WX, WZ, WY, WV. Those are 4 different rays, all with the endpoint W. Which of these rays are opposite? Well, clearly WZ and WY are opposite, and then WV and WX are opposite rays. It says, let's see here, WX and WY have a common blank. WX and WY have a common endpoint, okay, but are not opposite rays. Okay, they're not opposite rays. They are not. They do not form a straight angle. Okay, so they are not opposite rays. It says give another name for segment YW. Well, WY. Okay, so when you're talking about segments, the only other name is just flip-flop the letters. Or the points, I should say. It says, are VX and XV the same ray? Clearly not. Okay, they don't have the same endpoint. Okay, they don't have the same endpoint. So they cannot be the same ray. Over here it says VX and VW. Okay, VX and VW. Now if we look at those 2 rays, right, the endpoint is V. So VX says start here, go through X, and keep going. And then VW says start at V, go through W, and keep going. So clearly, I think once I trace it, it's pretty obvious that they are, in fact, the same ray. All right. And now the final thing that we're going to look at here are intersecting figures. Okay. And so when we sketch these, right, so the intersection is the set of all points that they have in common. So the 2 crossing lines is pretty straightforward, right? You have one line, you have another line, they intersect right there. When I say right there, that thing I'm talking about, the intersection of 2 lines is a point. Okay, of 2 distinct lines is 1 point. The intersection of 2 planes, all right, this ought to be interesting. I'm not a very good sketching. So there's one plane, and we'll say there's another one. Okay, good enough. That's all. That's the best I'm going to do. Okay, so you notice the intersection here is this guy right here. Okay, but remember, the planes extend forever. So your initial thought is, well, the intersection of 2 planes is a segment, but since they extend forever, that means that the intersection of 2 planes is a line. Okay, not a segment. A plane and a line that intersect in one spot. So something like this. There's that guy, and then I'll draw the line. Does it say line? Yeah, line. So maybe something like this. So we're here, and they intersect right there. Okay. Well, that intersection is a point. And finally, a plane and a line that is in the plane. So you draw your plane, and then the line is actually inside of the plane. Okay, and that intersection there now, since the line's in the plane, the intersection of the plane and the line is the entire line. Okay, it's not a point anymore because it lies inside the plane. So again, I know I went quickly through the notes, but that's the idea behind them, is just to give you a brief idea of what we're looking at, and then when you come to class, we'll refine your thinking, answer any questions that you might have, and hopefully build on this these notes.